All right, let's look at a very simple Linux buffer overflow. And this is one that's just going to lead to command injection. So we get to the right one here, ED201C. Okay. All right. So what we got here, if I do ls, there's a file called buff.c. This is a program with a very simple buffer overflow, and it's pretty much a contrived example. So the main program is down here. It's going to read in a name, and the name can be up to 200 characters long. Then it's going to call this BO function with name and a fixed string of date. And the idea is this is a name, it's going to say hello to you, and this is a command it's going to execute. And when you go in the buffer overflow function, it defines those two variables, the command and the name, and it shows you the locations where they're stored. And then it copies the name that came in into the name N variable and the command that came in into the C variable. And this is the buffer overflow. The problem is your name that came in could be up to 200 characters long, but the name variable here is only 40 characters long, and string copy is not aware of that. So it will blithely copy a name even when it's too big to fit in the N variable. And then it will do these two things. It will print goodbye to your name, and then it will execute the command using system. So if you run this program, buff, all right, and you put your name is short, then it works fine. It says goodbye, Sam, executing command date. And here it tells you the name is at location 8470, and the command is at 8498 in hexadecimal, so a little more than 40 bytes further along. So that's fine. And that means, of course, if you were to put in 40 characters, 5, 6, 7, 8, 9, there's 10. So if I put in 10, 20, 30, 40, and then ls, then it overwrote the date variable because the name was at 30 and the command was at 58, which is 28 in hexadecimal, which is 2 16s plus 8 for 40. So the name contained these 40 characters, and the last 2 characters went to the command, and it became ls. So now, if I put this in the clipboard, I now have command injection. I can put in ls, who am I, date, and other commands, and there they go. Here's the ls, here's who I am, here's the date. So you have command injection caused by a buffer overflow. This type of buffer overflow is not the famous kind that gives you complete control of the box, although it does. In this case, this buffer overflow is a rarer one. There. Now let's see. I just want to cat buff.c. Okay. This buffer overflow is where you leak out of one variable into another variable, which is not the most common one, but it turns out, by the way, this is the hardest one to stop. Even the defenses that Windows has and later versions of Linux, like stack cookies, will not stop this kind of buffer overflow. It's actually very hard to stop. But usually you don't get command injection because it's not very common that a string stored in your program is executed as a command, but it does happen. So that's the simplest Linux buffer overflow.